First, we're going to have Christian Hogg. He is a physical oceanographer, formerly from the Liebitz Institute of Marine Sciences in Kiel, Germany. And it was in 1994 that Christian formed Mariscope Maristechnik. And he did this out of necessity because he was working, trying to use some ROVs for marine mammal research and was finding nothing that was quite adequate. So he decided to develop his own technology, and that's where Mariscope was born. The company also extended into a family collaboration where his wife and two sons also became involved. So today, Mariscope has a wide product portfolio with many special developments and systems and excel at custom work. One such development was acquiring the technology transfer from the UVC LED Anti-Fouling technology from the IOW at Leibniz and putting it into serial production for many different industries that currently battle with biofouling. So that is Christian, and I'm just going to introduce Vincent Kelly. He is a chemical oceanographer and founder of GreenEyes. He has been deploying nutrient sensors and moored oceanographic instruments since about 1999. And it was in 2005 where he and his professor and mentor at the University of Maryland Center for Environmental Science was working on how to improve monitoring instruments' performances. So it was then, right there and then, that GreenEyes was founded and ProbeGuard was born, which allowed for a comprehensive solution to biofouling on moored sensors. And today, Vince leads GreenEyes on the advancement of field nutrient monitoring systems, real-time data displays and systems, and reducing the servicing of moored water quality sensors, which is all our dream. So I promise you, you won't find two more people that encompass passion about what they do, the water conservation and preservation, and aiming at providing, trying to provide accurate and reliable instruments and data collection. So let's get on to these exciting talks, and I'm going to pass the screen over to Christian, if you would like to begin.
Good morning, good afternoon, everybody. At the moment, I'm in South America, so I'm 6 hours back. Here it's 1 o'clock in the afternoon. So I will start my presentation. I'll try. Let me see. Is it visible?
Yes, it's good to go.
Okay. So in my presentation, I want to talk about, in this case, anti-fouling UVC lights. Short introduction about Mariscope and biofouling. Then we have a closer look to the lamps themselves and how they function and how they are programmed. Some characteristics, and I think the most important part is the case studies, and to finish with conclusions. So as Andrea already mentioned, we started 30 years ago. We started really developing ROVs, and until now it's all developed and manufactured in-house in our facilities in Germany, and in the future also in South America. Basically, we build modular systems so that we can change and use components from all the ROVs and reduce the costs. We do a lot of custom design, prototyping, and apart from ROVs, we manufacture like drop cams, tout systems, and a lot of other stuff. So we are based in northern Germany, in Kiel, where I studied. And then 2001, we opened a facility in Chile, in South America, because of the strong demand in the aquaculture industry. And 2014, on the opposite side, on the Atlantic coast in Puerto Madryn in Argentina. So basically, our systems are very modular. We have interchangeable components. We try to use as much as possible industrial modules so that we have lower cost and easy replacement. We give lifetime warranty on our systems, and we have minimum maintenance and maintenance costs. And we try to customize everything so that our customers really get what they need and not just standard equipment. So today we have this problem here already. Obviously, everybody knows of. In this picture here, if you can see my mouse, this is a Nortec profiler, what's left of it. And this is fouling in 3 to 6 months here in South America. We have very strong fouling problems. So everything that's underwater, as you know, after a couple of hours starts with fouling. And well, we have obviously marine coatings and other components that are used nowadays to prevent fouling in some way. We think that ultraviolet C UVC light is a very good option because it's free of contaminants. So basically, we use UV light in the wavelengths normally between 200 and 280 nanometers. And this is, at the end, is disrupting the DNA of the biology underwater. So for the lamps, we have very high efficiency in different types of surfaces. We will see it afterwards in the case studies. The lights nowadays are very efficient and low energy consuming, so that we can also battery power them. They're very effective. In fact, nowadays we are also making trials burning already fouled surfaces with it, and it's functioning. So the quality of the surfaces is maintained for a long period. It's obviously non-polluting since we have no chemicals in the water. And we can program and adapt the lights to different applications. So the early development was done in the Leibniz Institute for Baltic Research in Warnemünde in Germany. They had very strong problems, biofouling problems in permanent observation areas they had in the Baltic Sea through the BSH, that's the Bundesanstalt für Wasserschall, für Seeschifffahrt und Hydrographie in Hamburg. So the EOW in Rostock operates a couple of these sites, and the permanent sensors had obviously fouling and had problems with the data quality. So they started to develop these lights, and they made field trials from 2019 on. And the man in charge is Robert Maas. And when he finished the trials, the statement is here that all targets were kept clear and free of fouling permanently. So the sensors were giving very high data quality. So we go to the lamps themselves. We have 4 types at the moment. We have a radial and an axial configuration, so that you can see those here. And we have 2 types of cones. So we have a standard 70-degree light cone, that is, you can see it here. These caps here are protection caps, so that you can use them outside the water to see if the lights are functioning correctly and programmed correctly. And then we have a focused version with a very thin angle of 18 degrees. And you can see here on the drawing that this is here, the LED, and we have to adapt special lenses to the light to get it focused in 18 degrees light cone. This was done basically in relation to the seabird sensors, because they wanted to have focused light for their fouling problem on the seabirds. So what we see here next is the programmer and the light. You can see that we are able to program duty cycles, so on-off cycles. We can program the duration of the on cycle and the duration of the off cycle, but we can also program very easily the power output, the light output that we have on the light. And this is very important. We will see it afterwards due to the lifespan of the LED. So this box comes with a light normally, and you can use one box if you have several lights to program each light with just one box. It's very, very easy to use and self-explaining. So basically, the characteristics are a standard operational depth of 150 meters, because normally you don't have fouling deeper than that. But if you have special applications where you need a higher pressure resistance, we can obviously do that. As you can see, and I will show it afterwards in real, the dimensions are very compact. Voltage is variable from 10 to 30 volts. And the maximum consumption is 1 watt. So here we have an example of an installation that was done from the EOV, and you see how heavily fouled it got. This is when installed, and this is after several months. So you see that the light is keeping this area completely free of fouling, although the back part of the light is obviously fouled too. So in order to have more information, because we have a lot of clients, most of them are not willing to share their experiences, so we started our own case studies, and we will see a video now. We had a trial done with fishing nets with a very small mesh, so that we have a good area, good surface that fouling is just growing very fast. And we had two lamps. We have two lamps on this system, and we can see here we have two duty cycles. One is with 1 second on and 1 second off, with a nominal power of 40 milliwatts light power, and the other one is 1 on and 4 seconds off. So the video will show the situation after 1 week. You see that there is already some fouling going on the net. This is 1 week after installation. We are in a summer period, so the growth is quite fast. Then we have an image after 7 weeks. So you can see on the left side, the footprint is a bit smaller than on the right side. And this is because of the different duty cycle. This is
Christian?
one. Yes.
Sorry to interrupt. The oh yeah, here we go. Is this still the video?
Yes.
We're still videoing. Yeah. Okay. Good.
So we have here a bit smaller footprint. We're 25 centimeters away with the light. And this is 1 second on, 1 second off. 1 second on, 4 seconds off. And on the right side, we have 1 second on, 4 seconds off. Any questions about that? Okay. So when we look at the mesh, the part that receive UVC light look like this, and the parts that are without light are heavily fouled. So what we tried afterwards is we took the light with 1 second on, 4 seconds off, so the one that's powering less. We changed the angle, the inclination, and we tried to burn the fouled area. So you can see now in the video that in the upper part, it starts, the refouling started immediately, and here it starts to clear, and this is the part where the light is focused now, and it's burning the fouling that's already on the net. Next step will be to change and to increase the duty cycle to 1-1, so 1 second on, 1 second off, in order to decrease the time that is needed to burn the fouling. So let me show you a small video about that. You can see it on here in the part, it's already getting clearer. So the light is efficiently burning the area that was heavily fouled. So it's in this area here. And in the lower part, it's refouling. So it's growing again. We were not sure about that, if it's really strong enough to burn already fouled areas, and it looks pretty much like this. Here we have another case study. This is the first deployment was done in 18th of June of 2021. This is a Nortec AVAC ADCP. It's moored like 23 meters of depth. We have the light here, and it was inspected. June here is wintertime, so it was inspected in October. It's like early spring, and we see that the light was not focused perfectly. So this area is free of fouling, and here we have some fouling. So we had to readjust a little bit the light, but you see that's completely free after 3 months of use. Same situation, same spot. From October 28th, there was a midget before, and we re-inspected after the summer. So we have like 5 months over the summer to the March 2022. You see this area is completely full of algae, but these are macroalgae. They are not fouled on top of the system. It's just that they were brought by current. And you see the size. Here's the diver. He's cleaning up, but you see in this area is the AVAC. So the same AVAC we saw before, the light is completely fouled on the back. And once the diver took off the big macroalgae, you see that the head is completely clean of fouling. So it was in the water from June to March with the light on, and the system is free of fouling. No maintenance at all in between, apart from the one you saw. So I would like to go to some maths just to give you an idea. We have here the light power, 40 milliwatts, 20 milliwatts, and 10 milliwatts of output power of light power, different voltages. And what we see here, and that's basically what I want to show, is that the most efficient system is when you use low voltage. So this is consumption in watts when the power is on, and in watts when the power is off. And you see that the power consumption goes up with the voltage. So the best is to power it as low as possible. This is very important, and it's non-linear. When I half the light power output, we have more than half the power that is needed to to function correctly. So it's non-linear, and we try always, when we build battery packs for customers, we try to keep the voltage down. If the voltage is already given by, for example, the batteries of a buoy, then we obviously adapt to that. But the best case scenarios with 9 volts, and when you lower the light output, you can see that the percentage, so proportionally, the power is high. So it's losing efficiency when you go down in the power output of the light. So it's not always the best. The best is to keep the power quite high and to reduce the duty cycle. So often the question is, how long do they last? Well, we have systems in the water since nearly 2 years at the moment, so they're still running. The manufacturer of the LED says that the lifetime at 70% power output is 3,000 hours. I have to say that these LEDs have nominal 100 milliwatts. We only use 40 milliwatts. So we can think about minimum double the life expectancy, so like 5,000 hours. And this is permanent power. When we use 1.1, we would have 10,000 hours. And when we use 1.4 duty cycles, then we have like 20,000 hours of lifespan. Tests were made at 38 degrees on the solder point, and underwater we have less than that. So we assume that we will have even better values than this one shown here in this table. So UVC lights are good for fouling prevention and elimination. They consume very small amount of energy, if you can see, if you have seen also, and they are quite versatile. You can we in fact are developing now like lights for bigger areas, for bigger surfaces, than the ones that we have individually. Since this will be posted and shown also on the channels, here's a couple of references and any kind of additional information and prices, please refer to Aquatic Sensors. Thank you very much.
Awesome. Thank you. Thanks, Christian. Vince, if you are ready to load your presentation now, you are up. You just have to unmute yourself and the tricky mute button, and away you go.
Maybe I'll unmute for my presentation.
Okay, let's do that. Let's try it that way.
Okay, Christian, that was really good talk. Interesting stuff. Quite different biofouling applications from GreenEyes ProbeGuard, but we've certainly made a lot of progress in the industry on a difficult problem, biofouling. And I'll talk about a little different strategy. But first, I really need to thank Andrea for a great introduction. Andrea, you're going to have to give all my introductions for all my talks going forward. So no good deed goes unpunished. And also thanks to Andrea and Patrick at Aquatic Sensors for putting the webinar together. I haven't known the two of them for very long, but I'm really impressed. So whether it's biofouling solutions or other products that they represent, I would encourage you to just call with them and talk and see if they have some solutions to make your monitoring or instrumentation chores less difficult. So again, I'm Vince Kelly from GreenEyes, and I'm going to talk to you today about ProbeGuard, a comprehensive biofouling solution that we developed some years ago. And a little background to start on GreenEyes. I founded the company in 2005 based on some nutrient monitoring, system integration, and real-time data displays that I developed at the University of Maryland Center for Environmental Science in Cambridge, Maryland, while working closely with my advisor and boss, mentor, Dr. Luke Cottaspati. So most of our customers today are USGS, USDA, environmental consulting companies, state environmental agencies, not-for-profit environmental groups, and now even a few local government monitoring groups. And I've been at this for a good long time, and really the first new product that GreenEyes developed was ProbeGuard in conjunction with UMCs and Luke Cottaspati. We build all of our stuff at our facility in Easton, Maryland, which is across the Chesapeake Bay from Washington, D.C. We are right on the Delmarva Peninsula on the Chesapeake Bay. So the ProbeGuard method encloses the sensors in a chamber to prevent free communication with outside water. That's sort of step one. This reduces.
Vince, sorry to interrupt you, Vince. Do you want to put your PowerPoint up?
Oh,
No
I
worries.
didn't realize it wasn't. Yeah,
That's okay. I know.
Mm-hmm.
Okay, you're live now.
Thank you. Okay, so I will skip to the back to where I was. It's a ProbeGuard method. So essentially, we're enclosing the sensors in a chamber to block free communication with the ambient water. This, for starters, reduces photosynthetic activity, and it keeps small critters from making a home in the nooks and crevices of the probes on the sonde, which is, if you've ever been out in the field to collect these, is a common problem. When we start a sample, the chamber is opened, and we run a magnetically coupled stirrer to physically flush the chamber. And then we leave the chamber open for what we call ambient flow flushing. And this is a programmable amount of time where the windows are open and ambient flow can just continue to flush the sensors. So it could be 1, 2, or 3 minutes. Once the flushing is complete, the instrument collects its data, and we close the windows until the next time. So the majority of the time, the windows are closed. 4 to 6 times a day, we will inject a little bit of chlorine or another anti-foulant, sort of user choice. Most of the work's been done with chlorine, into the closed chamber with the stirrer running. So we're actually bathing all of the sensors, all pieces of it, in this anti-fouling solution. The windows stay closed until the next sample cycle. Then there are various methods to interface ProbeGuard with the sonde. ProbeGuard actually has internal data storage, data logging, control capabilities. So it can control its flushing, collect data from the sonde, and store it internally. We can also just synchronize the timing of ProbeGuard's opening and flushing and closing with the timing of the sensor, along with some generous buffers, so we don't ever sample with the windows closed. As well, we can use external data logger control. So this could be a Campbell Scientific data logger that sends commands to ProbeGuard and collects data from the instrument. But commonly, it's our own proprietary water-to-web system, where we have a small Linux computer issuing commands to ProbeGuard, collecting data from the instrument, and then it sends the data out in real time to the internet, both in text mode and plot modes, along with alarms or notifications about something interesting happening. Many of these could be customized if you want to know when salinity reaches a certain limit or oxygen. We can set it up to email you when that happens. Power consumption is similar to the sonde. I think I mentioned the stirrer is magnetically coupled. These are milliamps to run the stirrer and the motor that moves the cylinders on ProbeGuard, and they don't move for very long. You know, the cylinder only moves 1/8 of a revolution, so it's really milliwatts. The stirrer is milliamps, and during sleep, we're looking at microamps during sleep as well. Normally, we use 3 months of biofouling protection without any servicing, with 1 charge in the chlorine chamber. We think recently we're going to be able to expand it beyond 3 months, but we can say with confidence that we can get 3 months. So just a few different views of ProbeGuard. The panel on the left, you can see ProbeGuard with the windows open, and this is how water can flow through freely. You can see this chlorine chamber on the left. There's a blow up in the next panel to the right of the chlorine chamber with the stirrer in between. So it's sort of a ducted fan to maximize efficiency, both space and stirring efficiency. Again, this stirrer propeller is magnetically coupled, so there's no seals to worry about. And the chlorine, as we put about 30 grams of chlorine for 3 months, it's stored inside this donut-shaped thing here. You can also see the ends of the probes of a YSI EXO sticking down into the chamber. Next panel to the right, we have a ProbeGuard with the deployment screen. So this is just a copper screen, keep any critters in and out and anything from interfering with the rotation of the cylinder. the copper doesn't really provide any anti-fouling protection because copper has no real field effect. So that's why if you've used copper in the field and you put copper tape on probes, the tape is usually clean, but the sensing parts are not so much maybe. But we do want to put a copper screen on to prevent any objects from getting into the windows. And then the photo on the right is ProbeGuard with an EXO connected. We use different attachment rings. It's this disc at the top with different threads to adapt to different SONs. We've done most of the sensors from YSI, Hawk, and a few other companies as well. Okay. So just a few photos for evidence of efficacy. The picture on the left is of two SONs. The one on the bottom was protected by ProbeGuard. You can see nice shiny probes, and the sensor, the probe on the top, just had traditional biofouling protection, and you can see that it's really been colonized by barnacles. In our data sheet that you can reach out to Patrick or Andrea for, it shows the data associated with this deployment, and you can see pretty clearly how oxygen and other parameters drop off quickly in this deployment. The photo on the right is taken from a USGS internal publication done by Kurt Weidick, who did a pretty intensive investigation of ProbeGuard. The YSI SON on the right has their standard protection, biofouling protection, and the one on the left was enclosed in ProbeGuard. Again, pretty startling differences. I think both of these systems were out in the water for about 10 or 12 weeks. The one on the left was Chesapeake Bay, a tributary of the Chesapeake Bay, not far from Easton, Maryland. The one on the right was the other coast, San Francisco Bay. And mentioned earlier that one of the interface methods to synchronize ProbeGuard with the SOND is an external controller and our own water web system. So this has turned out to work pretty well. So the photo on the left, you see the pipe in the water that holds the SOND and ProbeGuard with a couple cables that run into our electronics box or water to web box, which has a small Raspberry Pi or Linux-based computer, battery, charge controller, and a cell modem. And this system allows us to process the data in real time on location and then send it out to websites at a user-defined interval. Usually we do it once an hour, but it could certainly be faster. As well as remote control. So if we want to change some type of parameter or do some kind of an investigation, we can remotely log into that Raspberry Pi and operate it like it's on the desk in front of you. This has been pretty nice. We, as I mentioned, we have daily email alarms, or excuse me, daily updates. It'll email you the results that day, as well as the website which has everything, and a variety of alarms. So it can be easily customizable to notifications about certain activities that certain trends in data or something like that. Here's just a simple example of some data that I clipped off of the website. This is from a coastal bay in Virginia, dissolved oxygen, but these are the types of plots that our system puts out for every parameter. The data is, as I said, available on a website, as well as archived on the website. So if you were interested in learning anything more about ProbeGuard, please reach out to Patrick or Andrea, and they'd be happy to discuss your specific application, generate a quote for you. And then I'll just conclude by giving you a live demonstration of ProbeGuard. I think I need to stop my share. Okay, so what you're seeing, and Andrea, am I good here? Are you seeing what I think you're seeing?
Yeah, you can just maybe pull it back a little bit more. Perfect. Yeah.
So
Or
just
in a
give you
little.
picture. So
Perfect,
standard EXO, and it's in our demonstration tube that is filled with water. And there's ProbeGuard. So you might wonder, ProbeGuard adds about 1 foot to the length of an EXO when it's in the field. It can be deployed vertically or horizontally. Apologize if I've made anyone seasick, motion sick. Okay. So as you see it now, the windows are closed. And then when it's time to sample, we just send a simple command. It's going to open the windows. It's going to run the stir in a reverse direction to displace any sediment that might accumulate. And then it's going to run the stir for a programmed interval in the forward direction to direct fresh ambient water to the sensors. And this stir flushing period is programmable. And I think we've accelerated this for the demo. But normally we run the stir for 30 seconds, and then we might leave the window open for 1 to 3 minutes after that for just ambient flow flushing. So ordinarily, ProbeGuard's closed. It opens an eighth, moves an eighth of a revolution to open, stirs, flushes, eighth of a revolution back. And then to introduce the chlorine, we don't use a pump or anything. And so we have this chlorine chamber. I'll just give the command. And it just opens a valve on this chamber, and we use ambient water as diluent for chlorine. So we can pack a large charge of chlorine as a dry pellets and use the ambient water to dilute it. So we don't have a lot of space. There's no physical pumps or anything like that. I'll just do that once more. So it's just going to open a valve on the chamber, close it, run the stir, bathe all the sensors in the anti-fouling solution, and then wait for the next cycle. Okay, I think that's basically it for me.
Awesome. No, that was great. As you can see, we've got two very different technologies. So question to both of you, I'll just let you go first, Vince, because you're unmuted. Can these work in all kinds of water, like fresh and marine?
Yeah, we've the fouling's usually a bit stronger in estuarine environments, but it has no problem with very high productivity waters, as well as freshwater. We've done significant tests in both zebra mussels, all those things, barnacles. They don't like chlorine.
Oh, and Christian?
Yes, sure. UV light is ready to go in every kind of water. Yes.
Awesome. And if I'm not mistaken, you use them even in like well boats, right, as well? Like use UV
Well,
lights also.
we are starting to talk to the wellboat guys. They have other systems they use, but we are not only on wellboats. We're looking now to probably work with the well, to keep clean the sea chests of the ships. They have always problems, so we are trying to develop a special panel that is usable for the sea chests, for example.
Yeah.
So
yeah.
I have a light here if you want to see it.
Yeah.
It's not very big. You can see it here. I have the programmer here on my desk, and I just switch it on, and you will see it flash. We have to keep the cap because of the UVC light. So it's easy to mount, it's easy to install, and well, basically free of maintenance.
Awesome. And how big is the programmer, just for hand size?
Yeah, it's
This way, yeah. Oh,
very small.
very good. Does anybody else have any other questions, or can I? Oh, I think Ian, you want to ask a question?
Yeah, Christian, I have a question for both gentlemen here. But Christian, can you comment on, so you have a programming module, and then do you disconnect that and then hook your cable into like a battery or power? I guess one of the things what I'm trying to get at here is, so normally one of the issues we have is, how do you tie in these external anti-fouling units, or an external unit, an extra unit into our data logger? And so one of the things that I've had, so taking a step back, we usually use Seabird products, and we tie those into a centralized data logger. And so we've been limited by the number of ports. And this isn't necessarily your issue. It's just one of the things I'm bringing up, is that we either have to split out the power into a Y, so we have one cable that goes into the sampling unit, and then we have another cable that splits out and goes into, say, an anti-fouling or your sensor. And so how do you, after you disconnect that from the programming module, how do you integrate that into the sampling system?
Well, you put a blind plug on that if it's just for transportation, but once you're on the site, you connect to the cable, the power cable. The programming is inside the memory, so it will keep the programming that you did. And if you want a standalone version, we connect here battery system, standalone one.
So it's the programming's internal to it, so all you need is power.
Yeah.
Okay.
Yeah, and Vince, just on the same note, do you provide battery as well with the ProbeGuard?
We do with our water to web systems, because we're going to use a solar panel and a battery inside that box. If there's no telemetry, where it's completely standalone, then we would just supply a custom battery pack, depending upon how long you want to keep it out. But it'd be relatively small. 8 D cells would go for several months.
Ian, if you don't mind me asking, how deep are you working?
I mean, for our typical, so I work for one of the ocean observing systems, or a couple of the ocean observing systems here in California that are NOAA or IU's based. And our sensors specifically, and the neat thing is, I'd like to pass, I'm not sure how this recording is going to be available to other people, but I'd like to pass this off to our colleagues in the ocean observing systems, if that's possible, or I can just also print to the website, or but that would be cool, just because everybody's using, like I said, we use Seabirds, but other people use the YSI probes. And so I think it would be very helpful for all of us just to think about this. But we here, so I work at Cal Poly in San Luis Obispo, which is central coast of California, or southern central California coast, between LA and San Francisco. And we have a mooring that's roughly 10 feet deep. It's on a pole, but it's moored at a specific depth. We have some mobile profilers. We have some other sensors that are in a couple feet of depth, depending on the tide. We've got about a 6-foot tide swing. And at the other point, we also do, for independent research projects, we put stuff out probably in the like 50-foot to 100-foot depth range. So, and thinking about these and how we can incorporate these would be helpful also. But we have lots of fouling, and it's also springtime, or moving spring into summertime. So it's I was just diving yesterday on a sensor that looked very similar to some of the deployments that both of you had.
Right, with the macroalgae, for sure. No, that's interesting. If Vince and Christian, you want to comment on the depth rating of your instruments?
I mentioned it. It was standard is 150 meters, but we can go deeper. So if you have some kind of whatever sensor that's going deeper and coming back, we can do whatever depth. So we work on full ocean depth, 6,000 meters with other systems, so we don't have any problems in increasing the depth.
Yeah, for ProbeGuard, 50 meters.
Okay, good. Does
I have
anybody
one more
else?
question if you have
Yeah,
a second,
absolutely.
Andrew.
Yeah.
Christian, I believe in the study that you showed with the mesh that was, I think you said 25 centimeters from the light to the fouling surface or the mesh. Is that a typical distance away from the sensor, or what would, because I'm trying to think of the cone, because you had two different cones, and just how those different cones would apply to different depths, or say a maximum depth that anti-foulant light could be deployed away from a sensor or surface.
So the maximum that was tested also by EOV was 1 meter away. 1 meter away, and then you have big footprint.
Okay, and that works well at the 1 meter.
Yes, but
okay.
We saw that it depends on the duty cycle. So if you want to have a long-lasting light, then you reduce the duty cycle, and then you have to go near the fouling area. Obviously, depends obviously also on the area where you are. We have here extreme fouling going on, so we have to illuminate a little bit more than maybe in the Mediterranean Sea or in Europe or whatever. So
excuse me.
We have seen that we are good enough for a footprint of 25 centimeters, being away 25 centimeters with a 1 second on, 4 second off duty cycle. If we go away half a meter, we tried, then 1.4 in our area is not good enough. Then we have to power 1 second on, 1 second off.
Okay.
So it depends a little bit on where you are, and obviously we are, in this case, we are very near to the surface. Okay. If you go deeper, it's slower, the foul.
Okay. All right. Thank you, guys. Very cool products. I appreciate people trying to tackle this issue.
Yeah, no, interesting hearing everybody's applications. Leslie just had a question for Christian about using a UVC on a glider or any other AUV. Leslie, have you actually experienced biofouling in this type of application?
Yes, we definitely have it on gliders that I've seen. I haven't seen a long enough mission on a regular AUV to see that, but definitely on gliders.
Yeah, interesting. Christian, have you done any of those?
No, not until now, but I don't see any problems. I see the question that additional power on gliders would be tricky, but as I said, the consumption is very low, so we could deliver a power supply for the lamp and use a standalone version maybe. Maybe we can go in details. It's interesting. We haven't been approached by anyone using gliders with that problem.
Yeah. Yeah. Thanks,
Leslie, I just saw your comment. This is Vince Kelly about nice to hear about the Pi use. And we are huge fans of the Raspberry Pi. It's just was one of the best decisions that I made to use for our controllers. They're about as powerful as a regular Windows PC was a few years ago, but much lower power and the size of a credit card. So yeah, we're big Pi fans at GreenEyes.
That made me light up. Like you couldn't see my face, but trust me, I was smiling. I'm a big open source hardware fan. So, and there's a bunch of scientists that are, trying to solve their own problems. So, inside I'm like, it'd be cool if you offered like the open source version since you're already using a Pi, but I totally understand the need for the profit end too, so.
Very cool. I know we have some different users on here from different industries. Does anybody want to currently talk about any other biofouling issues they have on any sort of utilities or any sort of farming, that sort of thing? I don't want to point anybody out, but I'd love to hear, where you're struggling, because we've got two of the experts on here that can answer those questions for you. If not, you're going to hear me answer some questions or ask some questions, not answer them. Christian, have you or Vince, have you guys actually have you deployed already in aquaculture? Do you have any users in this industry?
I'll just jump in. We have not yet. And potentially it would work well at offshore aquaculture for sure. We have a lot of oyster aquaculture going on the eastern shore of Maryland, but they don't do too many sensor measurements as far as I'm aware of. Although I should say, now that you've made me rattle my brain, Andrea, we did have an instrument set up at Horn Point where measuring water that was supplying the oyster hatchery. So yes, we have done some aquaculture work.
Very cool.
Well, we are here in the main aquaculture area. The production in Chile is as high as in Norway, so the farms are full of sensors. The technology is quite new here, so we started with some ports. Also, the picture I showed from the AVAC is from an aquaculture port. So on the harvesting sites, they're still not in use, but we have inquiries. As I mentioned, it's quite new, the technology here, so it's a couple of years that we are selling in Europe, but in Chile it's just a couple of months. In the one port that I showed, this is 3 years old. It was the first unit that we sold here. And people are approaching now because they have a lot of instruments permanently in the water in the industry, oxygen sensors, CTDs, current meters, and so on and so on. So fouling is an issue permanently, and they're still on the edge of, well, there's nothing you can do, just clean, because that was what was done always, or use some chemicals. They use it, for example, for the nets, the fishing nets, the fish nets, the pens. They start to clean underwater, and they're now going back to anti-fouling paints, because cleaning underwater is a problem. So they're back to copper-based, very contaminated systems. But it's obviously not useful for sensors. So it is an issue, and yeah, the market is quite huge.
Yeah, that's interesting. That's Vince. Vince is multitasking. Thanks, Doug. Douglas actually just put a comment in here about water treatment plants and various types of flow cells. He taps from raw and processed water that's piped in. And for these sensors, it's important for monitoring and computer control applications, because obviously very important for water treatment plants. So can you explain how these products can be used in this application? He says we need live online data, and fouling can be tracked in the data series, but we would love to avoid this to limit operator cleaning cycles.
Well,
who wants to comment?
In my case, you just need to install the lamp and let it power. If you have land power, you can power it permanently if you want. Then you're sure that it's very well cleaned, everything. But obviously the lifespan is lowered, so the LED will not last so long. But in fact, we have here not just in water treatment plants, we have in power plants, we have in the cooling intakes and so on. They are using, for example, ADCPs to measure the flow, and then they want to keep the ADCP clean so that the data are good. And we're installing now 5 units here in the north of Chile with water intakes and ADCPs in the water intake, and we need to keep it clean. So I don't see any problem to install that in a water treatment plant.
Yeah, especially with land-based power.
Yes.
It'd be very easy. Even though I know you have very low power usage for your lamps, your LEDs. Vince, do you have a comment?
Certainly, whatever we can fit inside the chamber, we can keep very clean. So lots of different sensors, flow cells, camera as well. would be no problem. It's, you know, the real-time data is one of the signature products of GreenEyes that I started on back in the late 1990s. So we're sort of all about, you know, getting the data from the water to the web in real time, making it available. So there might be some, and there usually are some specific details about an application, but we would be, you know, happy to talk about that. But I don't see any real barriers to making this happen at a water treatment plant.
Great. And we just got a comment from Darian, who uses GreenEyes telemetry and the control system at the Virginia Institute of Marine Science. And he just says he's got 3 commercial clam and oyster hatcheries. So now you can add that to your portfolio, Vincent, as well.
Yeah. Darian, thanks for the comment. Yeah, I forgot that the one of her sites that, or really both of them are oyster hatcheries. So yes, maybe we're doing more in aquaculture than I realized, than I remember.
It's always good to have your fans join you and remind you of what it is that you do well. So we're just about at the hour mark. Does anybody have any other last burning comments or questions that we can get into Vincent, Christian? If not, I just want to say, you know, we're making strides in, you know, getting better data, because as soon as, you know, most areas, as soon as you put an instrument into the water, it's already starting to foul. So, you know, never mind trying to keep them calibrated, but we also need to keep them clean. And, you know, I think you guys have brought 2 really great technologies to the table for us to share with users. So thanks for your time today. Thanks for joining us on this webinar. Everybody else, thanks for your time. We'll send out the recording, so please feel free to share it, pass it along, watch it for your bedtime, sleepy time, whatever you need to do. Not that this is a sleepy webinar by any means, but whatever you need to do, pass it along and spread the word. So thanks for your time, everybody.
Thank you.
Thank you.
Thank you
Thanks for doing this.
Thank you.
Yeah, Patrick and Andrea, thanks very much, and thanks for everybody for taking the time to listen to us. And we're all available for questions.
Yes, if anybody wants to get in touch directly with Vince or Christian, we can make that happen. So we can pass on their information as well in our email when we forward the recording. I'm going to